Okay guys, if you're stuck, go ahead and look up because I want to show you. So as a reminder, the first thing you want to do is identify your number of valence electrons. So you got carbon, it has 4, chlorine has 7, but we have to multiply that by 4, which gives me 28. And so I have to add up 28 plus 4 for my carbon so that I can figure out the total number of electrons that needs to be in my picture. So when I made this diagram, the first thing I did was I did my central atom, so that's my carbon, because it comes first in my formula. So once I put my carbon down, I drew my 4 electrons around carbon, and then I placed a chlorine at every available dot. So when I did that, at first, I'm going to show you on a new paper, I had chlorine in the carbon in the middle, put 4 dots around carbon, and then I placed a chlorine at each place where there was a single dot. Okay, that way we could start to form a bond. Each of these chlorines gives me how many electrons? 7. So then I'm going to add all 7 of my dots. 1, 2, 3, 4, 5, 6, 7. So that is how each chlorine ends up with 2 dots in the middle. 1, 2, 3, 4, 5, 6, 7. So now this chlorine also has all the ones it needs. 1, 2, 3, 4, 5, 6, 7. And the last one, 1, 2, 3, 4, 5, 6, 7. So when I check it, they each have 8 electrons surrounding. Do I have any questions so far? Because you have to be able to do this yourself. Okay, the last thing that I want to do is I want to check. There's 2 things that I want to check. Thing number 1 is that they each have 8 electrons. The second thing I want to check is, hold on, that I have the total number that I wanted. So what was my total number that I wanted? The total number of electrons I need? 32. So I'm going to check that each has 8 first. So I'm going to go back to this picture because it's a little bit more clear. So when I look at my green circle, are there 8 dots in my green circle? Yes. Are there 8 in my yellow? Are there 8 in my purple? Are there 8 in my red? Are there 8 inside of my blue? Yes. So they all do have 8. So I'm going to check that step off. Do they have 32 total electrons in this picture? So it's going to take some time, but you want to make sure that you didn't miss any electrons, because if you miss one, it's going to be wrong. So when I count them all up, I do in fact get 32. So once you've checked both of those steps, any of the ones that are being shared turn into bonds. They turn into those single bonds. So my final answer should look like this. So I'm going to give us another 2 minutes now that I've re-shown you. Go ahead and try to finish the rest of them. If you're done, I'm going to come by right now and check.
I need a pen.
oxide and you passed it, do the other two. So maybe we're getting stuck there. Okay, go ahead and stop. I want to go over it so I can make sure we all get it. So let's look at NH3. How many dots does nitrogen have? Yeah, nitrogen. 5. Hydrogen. 1. Okay. I'm going to show you a slightly different way because I think some of us are struggling with this. So look up. I'm going to show you another way you can do this. Okay? So every hydrogen I'm going to write out this time. Okay? So that way I know exactly how many dots each one brings to the table. So when I do this, I'm going to write nitrogen in the middle, and I'm going to put hydrogen around it. Have I put any dots yet? No, and that's okay, because this is a new way that I'm going to show you. The next thing that I'm going to do, because this might be a little bit easier for a lot of you, I'm going to put 2 dots every place where they're going to be shared. So I put 2 dots right here, 2 dots right here, 2 dots right here, so that way they can form a bond. 2 dots will give me a bond. What does 2 dots give me? A bond, and they want to be bonded because they want to share. So how many dots do I have so far? 6. I needed how many total? 8. What's 8 minus 6? 2. So I got 2 dots left. Where can I put those last 2 dots? Where? Besides nitrogen, in this empty space. So that way nitrogen now has all 8. Hydrogen has the 2 that it likes. Does that make a little bit more sense? I'm going to show you again. Okay? So on the next one, we have carbon. How many does it like? 4. Oxygen? 6. And I'm going to write oxygen twice. So how many total electrons do we have? How many? What's 6 plus 6? What's, so 16, yeah. So we just add all these up. Add all these up. Okay, so let's try it this way. With what I just showed you, let's try it this way. So we have carbon, and now I'm going to place an oxygen and an oxygen. So how many dots did I say to place between the letters? How many dots we place? 2. So I'm going to put 2 dots between each set of letters. So how many dots do I have left now? So 16 minus 4 is what? 12. So I have 12 dots left. Okay, so I have to figure out how and where to place these remaining 12 dots so that every single atom has how many? 8. So we want to figure out how to make it have 8. So if I put my dots, I'm going to do this part in pencil because this is where it gets a little confusing. Okay, my dots are in pencil because I'm going to have to erase, so make sure you're using a pencil. So I got 2 dots right here, 2 dots right here. Is carbon happy? Yep, carbon is happy. If I put, so I'm going to take away 4 more dots, and now I have 8 left. So if I put 2 more dots here, and 2 more dots here, and 2 more dots here, is oxygen happy? Yes. So now I have 2 dots left. If I put my last 2 dots here, is this oxygen happy? No. So we're going to have to try it again. So this is going to be a process of trial and error. You're going to have to try and try again. Say that again.
How many does oxygen need?
Oxygen needs 8. They both need 8. They all need 8. Okay. What you're going to have to do in this case, when you do it, you're going to get 2 over here and 2 over here. These both form something called a double bond. So the carbon and oxygen are actually going to share 4 dots in the middle. So whenever we do these double bonds, they're not easy, but I don't believe any come up on your unit exam. So you should be okay. So do I have all 16 dots now? Yes or no? How many am I missing? 4. Okay. Where am I going to place these last 4? Because let's look at it. Carbon, is carbon happy? Yes or no? Yes. How many does oxygen need? Let's look at it. How many does it need? It needs 2 more. How many does this oxygen need? How many? 2. So they both need 2 more. So we're going to put 2 more on both of them. Did I use all of my dots now? Yes. So now this one works. This one is hard. Okay? It's very hard. It's okay, and it's not going to hurt my feelings if you get that one wrong. Okay? Just do the best you can. So let's try the next one using this new method. So we have boron. How many electrons does boron have? Fluorine. 7. And we got we have 3 fluorines. So how many total dots do we have? So we have 24 total. Okay? So let's place our boron in the center. It's our central atom. And I'm going to place fluorine around my boron. How many dots do I place between each boron and fluorine? 2. So I'm going to put 2 dots. 1, 2, 1, 2, 1, 2. So how many dots did I just use? 6. What's 24 minus 6? 18. So we have 18 left. So remember, boron was one of my special cases. Boron right here only needs 6 electrons. Does boron have 6? Yes. So this is done. We are finished with boron. How many atoms do we have left? How many we got left? No, guys. How many fluorines do we have left? 3. We got 3 left. So we have to split these 18 dots up with these 3 fluorines that we have left. So how many dots can each fluorine get? 6. So we're going to put 6 dots around each fluorine. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Does each fluorine now have 8 total? Yes or no? Yes. So we are finished with this one too. Give me a thumbs up if that method helped you a little bit more. Give me a sideways thumb if it confused you a little bit more. Give me a down thumb if you really didn't like that one and you liked the first way. Okay, so there are 2 different ways for you to do it. I don't care which one you use. Whichever one helps you better, use that method. So if you want to go back to the first one, that's fine. For the last one, you should have had oxygen and hydrogen. Oxygen has how many? 6. Hydrogen has how many? 1. So we should have had 6 around hydrogen. 6 around oxygen. And the hydrogens each bring 1 dot. So that is the final answer you should have had on my paper. The last thing I want to go back and do on each of these pictures, every single place where we have 2 dots, we need to turn those into lines because those lines represent that they're together. So we have N, H, 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 and then we have 2 lone pairs still. For this middle picture, it's going to look like this. For my fourth picture, it's going to look like this. And for the last picture, it's going to look like this. So again, anywhere where they are sharing dots, so they're sharing right here. Sorry, not those. They're sharing right here. They were sharing right here. So anywhere where they share, they're going to turn into lines. Okay, what I want us to do, because we don't have a lot of time left, I'm going to show you something on the back, so don't worry about doing this. Go to the back. Okay, so there's something called repulsion. So what repulsion means is the force away from other objects. So electrons are negative, and they do not like to be around other electrons. They're like, oh my god, get away from me, I hate you so much. They're like the worst enemies. Okay? So what happens when those electrons move is they start to form different shapes, depending on how many electrons are there. So y'all see all my shapes up here? We are going to learn all of these shapes. Okay? We have like the next 2 days to go over this, so you're going to be okay. The first one I want to talk about is this guy. Y'all see this? What does it look like? Like what? A chain. Kind of looks like a chain. True or false? A chain? Have you ever seen a chain, Mark? Looks like a chain. Like a piece of your chain. Now you agree? You just checked it? Okay, so in my chain, these electrons that are around all of the little models, they cause different shapes. So this one made a chain. This one, what do y'all think this one looks like? Kind of sits up a little bit. Huh? A jack? Yeah, like for your car?
No.
Oh, well, that's what I'm thinking of.
The toy jack. That's probably
Oh, yeah? What do y'all think this looks like? A what?
a L.
An L? A what?
A
Lang?
leg.
Leg?
Body part.
Kind of. What'd you say, Mark? A V. Kind of looks like the letter V. What about this guy? Fidget spinner. Anybody have any idea what this guy looks like? Joystick? Yeah, I can see that. Okay, so these are all our different shapes. Now we have to give them a slightly different name. So the first one that I want to name is this guy. Raise your hand if you think it looks like it's in a line. Straight line. Does it go in a straight line?
No.
Why you say it's crooked? Because of these?
It's in a straight line.
It's in a straight line now. It's still in a straight line, like my pencil. Y'all see that? It's still in a pretty straight line. So this one is called linear. So it is a compound with 2 single bonds, and it has 3 total atoms. So y'all see how we have 3 atoms here? 3 balls? It has 3 total atoms, and it forms a linear shape. So we're gonna draw what this looks like on your page. So it would be 3 atoms with 2 bonds. So what this would look like if we did our Lewis dot structure, beryllium usually has 2 electrons. Chlorine, do y'all remember how many? 7. So whenever we put all of our Lewis dots on our picture, y'all see how this all stays in a straight line? That is called a linear shape. So this would be linear. So if we looked at our picture, it forms the same idea as our picture if we did our dashes between. Chlorine with beryllium around it. Okay, the next one is going to be 2 single bonds. So 2 single bonds between 2 atoms, or sorry, between 3 atoms. And they have a lone pair of electrons. And it's going to form what's called a bent shape. So this guy is our little bent shape. Looks like a V. Looks like an elbow. Your elbow bends, your knee bends, your leg bends. So those parts that are bending is what this looks like. Okay, so we have our one central atom, and it has 2 other atoms connected to it. A common example of this is water. So the reason it bends, y'all see these little lone pairs that I just drew on top, the little 2 dots? Those 2 dots make these go away and they bend the entire shape. So instead of being straight, it bends it down. Instead of being straight, it bends it down. So instead of being like this, it bends it. So that is what this is going to look like. So a really, really common example is water, like we drew on the front. So it had hydrogen connected to oxygen, and those lone pairs made it bend. So instead of it being straight, it had to bend. Okay, the next one is this guy. So how many atoms do we have around the central atom? 3. So it is a compound with 3 atoms bonded to the central atom. Does anybody know what the prefix for 3 is? I heard it. Say it louder. 3 means what? What's the prefix? Tri. So it's called trigonal. So that word tri should be a big hint to you. Tri means 3. Trigonal, planar. The word planar means flat. So y'all see how this one lays flat on my page and I can spin it like a fidget spinner? Okay, that's exactly why, because it lays flat. So if you want to make yourself a note, this is our fidget spinner. I don't even know how to spell that. I think it's like this. Did I spell it? Yes, I'm a winner. Okay, so my little fidget spinner up here. We're going to draw ourselves a little picture so we remember what it looks like. So I have 1 in the middle, this is my central atom. Then I have 3 atoms hanging off my central atom. Okay, my next one is this guy. I'm gonna move my paper up so you can see a little better. Sad day. Okay, it's okay. I'll get it in a minute. Okay, my next one is this guy. So we have my central atom right here in the middle. How many do I have around the central atom? 3. So this is another one with 3 atoms around the central atom. But what you don't see, and I'm going to draw it on here, is this guy has a lone pair at the top. So similar to my bent guy, similar to this one, it's going to have a pair of electron that pushes it down so it can't be flat. So it has a lone pair. So my first word is also going to be trigonal because it has 3 electrons. But instead of it being flat, and I'm going to see if I can change this so you can see what it looks like. That didn't really work. I think it's upside down. It's upside down. So instead of it being flat, what does it look like? A pyramid. So what do you think it's called then? Trigonal?
Pyramid.
Close. Pyramidal. I'm going to show you how to spell it in a minute. Trigonal, pyramidal. I spelled it wrong. Cool. I'm so smart. It's wrong. If you want to spell it wrong, you can. I can't spell pyramidal. There we go. Pyramidal. So it kind of forms that shape of a pyramid. So let's go ahead and draw this in too. So I have my top, and there's a lone pair up here, so that pushes these 3 atoms down, and that's why it looks like a pyramid. Boom. This last guy, my joystick, okay? It has a central atom right here. How many pieces, green pieces, do we see? 4. So this one is called a compound with 4 atoms surrounding the central atom. It's called a tetrahedral. Tetris. Tetris. You can play Tetris with a joystick. Okay, so keep that in mind. Huh? Yeah, like on the old Atari. You used to use a joystick to play Tetris to move it back and forth. Okay? So that should be one way for you to be able to remember it. Tetris, joystick. So it kind of looks like our joystick. So it had 1 in the middle, 1 at the top, and 3 down at the bottom. So it forms my joystick. Tomorrow you're going to finish the rest of this, and I'm going to help you with some of it so we can see how it works. So go ahead and put your notes in your folder. Corey.